So today we're going to talk about what rate of change is and what slope is. So we're referring to basically how steep a line is when you graph the line. So let's start with rate of change. Now, rate of change is another way to refer to the slope of a line, the steepness of a line. And a rate of change is a comparison of two values. And they're compared to each other in fraction form. So your numerator is going to be whatever the change in your y is. Your denominator is going to be the change in your x value. All right, a lot of times they refer to that as your rise over your run. So another way to refer to your change in y and your change in x, a lot of times they'll draw a triangle. So that represents change in y, and change in x. So you might see it referred to in that form as well. All right, so if you have a line that's graphed, you basically want to determine the steepness of your line. So if you're going from one point to another point, you're comparing your rise to your run. And on graph paper, what you do is you'd literally count your boxes. How far up do you go? How far sideways do you go to get back on your line? Okay, so picture a stairway going on from one point to the other. How steep is that stairway? Okay, that's determining your rate of change, the slope of a line. Now, if you have a line heading in this direction, I want you to be able to read the line and determining if it's an uphill line or a downhill line. So you're always going to read a line from the left and go over to the right. So if you start on the left side of your graph, you can see that you're at the lower end of your line. And if you follow your line, you are going uphill. So in this direction, this is considered to be an uphill line. Okay. The slope of this line, just knowing it's uphill, is going to be positive. So this would be considered to be a positive slope. Now if you're heading in the other direction, again, you always start on the left side of your graph. So in this case, we're on top of the hill. And if you follow the line, you are going downhill. So that is considered a downhill line. And your slope here would be negative. Okay, you would have a negative slope on any downhill line. So that you can tell at a glance. All right, so what I want you to do is take the piece of graph paper that you were given earlier, and let's go ahead and put that here. All right, we're going to go ahead and get our x and y axis going. And I'm going to give you two ordered pairs to put on this graph. All right, I've got them here, but we're going to label them. I want A to be the ordered pair -3, 1. And let's have B have the ordered pair 2, 3. All right, so if I go to 2, 3, right 2, up 3, we've got a point there. Left 3, and up 1. So let's go ahead and connect those and make a line. And we're going to go ahead and determine the slope of the line, the rate of change. All right, so here, let's call this one was A and this one was B. It does not matter if you start at A or if you start at B, but what you need to do is travel from one point on your line to another point, only going vertically and horizontally, because slope is your rise over run. So to find your slope of AB, all right, from A to B, we use the letter M to represent slope. we can do the rise over the run. So if we do that with this line, again, you can start at A or start at B. If you start at A, rise is your numerator. And remember, rise is your up and down move. So you need to figure out how far up do you go until you're directly across from B. And you are going up 2 boxes. Up is a positive direction. So your slope is going to be a positive 2 for the numerator. And so when you go up 2, you're standing here. And you still need to get to the other point, which is over here. So now you have to move to the right 1, 2, 3, 4, 5 boxes. To the right 5 boxes. Your slope is a fraction, 2 over 5. So that is one way you can write the slope. That means for every 2 boxes you go up, you will go 5 boxes to the right. So if I wanted to find another point on this line, I'm going to follow the rise over run again. I can from here go up 2 boxes and write 5. 1, 2, 3, 4, 5. And the line is heading right to that point there. That would be another point on your line. Now let's say you went from B to A. Now remember, you've got to go vertically first. So if I go vertically, I would now need to move down because I need to get directly across from the point I want to get to. So I would go down 2 boxes. Down is a negative move. And so now I'm here, and I have to go left to 1, 2, 3, 4, 5 boxes. So this shows me my slope is a negative 2 over negative 5. But a negative divided by a negative, that is still a positive slope. So these are 2 ways you could write the slope for that line. All right, so let's take the point C. Let's make that at 4, negative 4. And let's put point D at negative 2, negative 2. Let's see if we can find the slope of CD. And technically, these are going to be lines I create, so I'll put the line symbol above that one as well. All right, let's plot these points to the right 4, down 4. All right, so that is where point C is going to be. And then D is to the left 2 and down 2. So there is D. All right, let's see if we can find the slope of that line. Again, we can start at C or we can start at D. We go from one point to the other. So for the slope of CD, rise over run. Change in Y over change in X. The change in Y is vertical, so if I start at C, I would have to determine if I go up or down to get right across from D, and I have to go up 1, 2 boxes. Up is a positive direction, so that would make the numerator a positive 2. So now I'm standing here, and then I have to go to the left to get to D, so count your boxes. 1, 2, 3, 4, 5, 6. That's a negative direction because I went left. Negative 2 over 6, or 2 over negative 6 in this case. Now that can be reduced, and so we can say the slope is a negative 1/3. Now if I started at D and went to C instead, I would have to go down first, down 2 boxes, so that would get me a negative 2, and that would land me here, and then I go right. Right is a positive 1, 2, 3, 4, 5, 6. And that reduces with my negative up in the numerator. These are both equivalent fractions. It's the fraction negative 1/3. The slope is negative, it is downhill. So you can write it either way. So that's how you find the rate of change or the slope if you're given a graph of a line. I also want you to be able to find the slope if you're given a table of values. Okay, so we have the graph and now we have the table. All right, so let's say I give you x and y values that go together to create a line, a linear function. If I use those values for x, let's say I use this for y. We want to find the rate of change or find the slope. So we need to remember that to find the slope, I'm not going to use rise over run right now because I'm not counting boxes on a graph. I'm going to refer to the change in y over the change in x. And I'm going to look at my table and I'm going to start with my y values, my range. And I want to see what is going on going from one to the other. I see that the x's have a pattern here. That means the y's are going to have some kind of pattern if it's a linear function. So to go from a -6 to a 2, and to go from a 2 to a 10, let's see what's going on. From a 2 to a 10, I know I'm adding 8. Is that the same thing that's going on here? If I take a -6 and I add 8 to that, will I get my 2? And I will. Add 8 to the 2, I get my 10. If I wanted to keep going, I know an 18 would be next. This is my pattern. The y's are going up by 8, and that would make the numerator a +8. So the x's, going up by 2 here, going up by 2 here. You've got the same change going on here, and you have the same change going on here. So we are going up by 2 for the change in x, so that's our denominator, +2. You can reduce that and make it 4 over 1, or you can simply say your slope is 4, or your rate of change is 4. So that's how you can determine your rate of change if you're given a table of values. Find how the y's are changing and compare that to how your x's are changing. Now this is a linear function because my rate of change is consistent all the way through the table. So you also need to be able to determine, if you are given a table, they might ask you, is this going to be a linear function? Would these points be a straight line? Okay. Without graphing the points, you could always plot the points, connect them, and if you get a triangle, you are not linear. But I want you to be able to determine it without graphing the points I give you. Okay, if this is going to be a straight line if we were to graph it, will it be a linear function? I'm going to give you a sideways table, because you might run into those on occasion. This time my domain will go across the top, my range will go across the bottom. We'll do one more. All right, the y values that are going to go along with this will be 7, 5, 3, and 0. Now, if this is a linear function, they are going to have a consistent rate of change. All right, so we need to find out, is the change in y over change in x consistent? Consistent rate of change, consistent slope. If you have one single straight line, your slope will be the same between any 2 points. So let's determine that. Change in y over change in x. Since I don't have a graph to count boxes, this is how I'm going to do it. All right, let's go from point to point. My change in y, let's start here. I'm going from a 7 to a 5. I'm going down by 2. So its partner up here would be going from 8 to 12. That is going up by 4. That's basically a -1/2 so far from my slope. Let's see if it's going to be equal. Let's go from the next points. 5 to a 3. All right, that's looking good. That again is going down by 2. Its partners are going from 12 to 16. We're good there. That also reduces to negative 1/2. So these two are the same steepness from each of these sets. Let's try the last set we have. Going from a 3 to a 0. Okay, we are a little bit different. We are going down by 3, whereas the partner is still going up by 4. So these two slopes are the same. So from here to here, we are linear. Then we change our steepness all of a sudden. This one is different. Since you have a different rate of change somewhere within your table, you have non-linear functions. So you have to be able to determine that if you have a table. And that's it for today's lesson.